Let's go ahead and start lesson 3.3, which covers applications of linear problems. In other words, word problems. Okay, I know your favorite thing to work on, which is word problems, but they're not so hard. I know all math teachers say that, but it's not so hard if you kind of know how to approach them and know kind of how to break them down. I think that's a pretty important thing to do. Now, for these particular problems, what we're going to do, the steps for solving them, one of the more important steps is going to be identifying a variable. Okay, that's what we want to do. We want to identify the variable. So for instance, we want to figure out what X is. What does X stand for? Does X represent, like in number 1, does it represent the number of students? Does it represent the number of tennis players? Does it represent the number of people on the newspaper staff? What does X identify with? That's the thing that we need to really make sure that we've identified that for sure, and it's part of the problem. Okay, and then kind of work your way around that X or N or whatever letter you have chosen for your variable. Okay, so this first example right here, let's kind of read through this. This first example, it says at Roosevelt High School, there are 6 more students on the newspaper staff than on the boys varsity tennis team. And total, there's 42 people in that club. So what we're looking for in this problem, it says how many students work on the newspaper and how many people are on the tennis team. So that's what we need to figure out from that information. All right, so algebraically, we're going to approach this algebraically. I mean, one thing I talked about during class, which was, you can do this brute force technique, which is kind of just a guess and check way of doing it, going, well, we know there's 42 students, so maybe, just keep trying different numbers. Let's say we try 30 and 12, because 30 and 12 adds up to 42. And if that doesn't work, try 35 newspaper staff people and 7 people on the tennis team. But like I said, that's a brute force plug in chug type of guess and check method, which works fine for a lot of people I know, but it also can be frustrating because you can go through a lot of iterations of the problem before you actually get to the actual answer. So we're going to talk about the algebraic way of doing this, not just the guess and check way of solving these problems. So for this one, we got what we want to do is identify. So let's say, because it says there's 6 more students on the newspaper than on the tennis team. Okay, the newspaper staff. So there's 6 more people on the newspaper staff than on the tennis team. So let's say T represents number of I'll just, not really writing good sentences here, but number of people on the tennis team. Okay, that's what that means. Okay, so the T will represent that. And then since it says that 6 more students are on the newspaper staff, you're tempted to use like a different letter, like an N for newspaper staff, or Y, X and Y, but we're not yet to systems of equations where you could perhaps assign 2 different variables. Okay, so for right now, we're going to solve this with 1 variable. And let's stick with T, but I'm going to do T plus 6. And that's going to represent the number of the newspaper. We're talking about the newspaper staff there. Okay, so those 2 expressions, T is an expression. I know it's just a letter, but T is an expression, and T plus 6 is an expression. And now what we want to do is just, crunch those together, put those things together into an equation and make them both equal to 42. Okay, so we're going to put that together. So let's go ahead and put our equation together, because that's what this is all about. I think at this point, hopefully at this point, solving the equations is not the tough part. I think at this point, setting up the equations is where the work needs to be done, and you need to kind of put the most effort into that. So the equation here is going to be T plus 6, because that's the newspaper staff. So this T represents the tennis team, and T plus 6 represents the newspaper staff. And we want those to both equal 42 because it says that in the problem. It says both those clubs, both those members of the groups add up to 42. So now it's just a matter of solving it. So I'm going to focus on the equation now because we figured out the equation. So it's going to be 2t plus 6 equals 42. Pardon my marks here. Do this, sorry. I'll close some of my windows. All right, and I'm going to try this again. Then subtract 6 from both sides. Rewrite the equation. So now we have 2t equals 36. Divide by 2. And I'm just going through the process of solving this using inverse operations. And that's really not what I'm teaching here. What I'm teaching here and what I want to get across is that you know how to set up the equation, how to set all this up, which I get is not the easiest thing to do. So we're going to do t equals 36 divided by 2 is 18. So there you go. So right there, 18 people are on the tennis team. Okay, so that's the tennis team. So varsity tennis team members there. And it says 6 more people are on the newspaper staff. So just add 6 to that. 18 plus 6 is 24. And there you go. So 24 are on the newspaper staff. And that's it. That's all the information we need for that problem. Okay. For the next one, number 2, a T-ball team for 5-year-olds has half as many girls as boys. If there are 15 children on the team, how many boys and how many are girls? So again, we want to stick with one variable. So for instance, it says there are half as many girls as boys. Now that can mean a couple different things. It can mean the number of boys, you take the number of boys divided by 2, and you get the number of girls, right? Let's say the number of boys is 20, divide that by 2, then there's 10 girls. If there's 30 boys, then there's half of that, 15 girls. If there's 6 boys, there's half of that, which makes 3 girls. I say 6 boys, 3 girls, right? And or you could think of it as double, right? Take the number of girls that there are, right? Take the number of girls. Let's say that's G. I'm going to prefer this way. I'm going to say G is going to equal the number of girls. And we're not going to use B for boys. We're going to do 2G, and that's going to represent the number of boys. Because that expression relates to G. It's dependent on that G, the number of girls. So the number of girls, and all we have to do is just kind of think this through. If the number of girls is 3, then the number of boys is going to be 2 times 3, 6. If the number of girls is 5, the number of boys is going to be 2 times 5, 10. So 5 and 10. See what I mean? And so setup wise, it's not too hard. So now we're going to do pretty much the same thing we did with number 1, which is just put that together, make it a sum. We're putting it together as a sum, and we're going to make it equal to, what does it say, 15 children. So we got to keep true to that number, 15 boys and girls. So you got G, number of girls, plus, oops, not just G, 2G, number of boys, and then we know that that's 15. And now we're solving it. This is the easy part now. This is the easy part, solving it. So you got 3G equals 15, divide by 3, divide that by 3, boom, bing, boom, and there you go. So G represents 5. 15 divided by 3 is 5. And so that's the number of girls. And the number of boys is going to be 10. So 5 girls, 10 boys. And we know it's 10 boys because it's double. the number of girls. It's stated in the problem. All right, so next, moving on to the steps for solving problems involving lengths. We're pretty much going to do the same thing here. I think sometimes when you're dealing with like geometry type problems or lengths or anything like this, drawing a picture is somewhat useful. I find that to be just being able to visualize it, draw it out, sometimes helps our brains kind of wrap itself around it and understand the problem better. So yeah, draw a picture, you know, this is all the steps I'm gonna write here. So that's my advice for these problems. So like for number 3, it says the carpenter has a 15-foot piece of wood, you know, a board, and it's being cut into 2 pieces, and one piece is 3 feet shorter than the other. Okay, so I'm just going to draw for this one. I'm just going to draw what might be the board. Okay, and we know that it was cut. You know, it was cut. Let's say it was cut right there. And I know that one piece is shorter than the other, you know, so one piece is 3 feet shorter than the other piece. So what I'm going to do on this one is I'm going to make this n, make that n right there, and that's the longer piece. And then we know the shorter piece is 3 feet shorter, 3 feet shorter. So whatever n is, that's going to be n minus 3. That's your expression right there. So the shorter piece is n minus 3, and the longer piece is going to be just n. And you can just think that through. Think that through. You know, if the longer piece is 5 feet, you know, if it's 5 feet, then the shorter piece is going to be 5 minus 3, which makes 2. Okay, so now let's go ahead and let's put the algebra together here and make the equation. So we got n minus 3 plus, you know, that's the shorter board, plus the longer board, n. And then we know that together, those are 15 feet. All right, now let's go ahead and solve it. So I put like terms together first. I'm going to add 3 to both sides. You get 2n equals 18. Divide by 2. We have one more step here. And there you have it. N equals 9 feet. Okay, so 9 feet. That represents what? Does that represent the shorter, or does it represent the longer board? Well, it represents n. And n in our picture, at least, n represents the longer part, you know, the longer cut piece of wood. So that's going to be 9. There, that's 9 feet. And then it says the shorter piece is n minus 3. So it's going to be 9 minus 3, and that's 6 feet. And then you can confirm that, you know, those two numbers right there make 15. 6 plus 9 makes 15 feet. All right, number 4, there's 2 lakes in the town of Roxbury, Big Lock Lake, what did I say, Big Lock? Lake Big Rock is 1,650 feet longer than Lake Little Rock. Together, they're 5,273 feet long. How long is each lake? Okay, so this is pretty much the same thing going on here. We've got, not that you have to draw a lake, but I'm just gonna, you got a lake here and you got another lake. Okay, one's bigger, one's smaller than the other. There's some waves on that lake. So there's 2 lakes, and Lake Big Rock is longer, it's bigger. And so let's say for the smaller lake, we just make that x, okay? And this one's going to represent x plus 1,650. All right. So because we know that the big lake, Big Rock, you know, Lake Big Rock, we know that that's bigger. So it's going to be whatever the smaller lake is plus 1,650. And let's put it together. So our equation is going to look something like this. And now I'm just going to solve it. So then you get 2x equals 3,623 feet. And now we just have to divide by 2. And we're going to get a decimal for that one. So when we do that, just going to use my calculator here. You get x equals 1,811.5 feet, so 0.5 feet. And then the other lake is going to be that number plus 1,650. And if you want to confirm it, just add these numbers up. Add this number plus this number. And what should it equal? It should equal that, right? You can do that on your own if you want to. That's it. Okay, now steps for solving consecutive number problems. Now, consecutive numbers are numbers that are one after another, right? So if you have, in the simplest way you could possibly put, if we have 1, 2, 3, 4, those are consecutive numbers, or they can be negative. They can have negative 15, negative 14, negative 13. They don't have to be all positive. Negative 12. You could have 0 in there as well. You could have like negative 2, negative 1, 0, 1, 2, 3, et cetera, et cetera, et cetera. So those are consecutive numbers, right? They're just one after another after another. All right, so those are consecutive. But sometimes you'll have consecutive even. And depending on the problem, the consecutive even can be anything. But just for example purposes, the consecutive even could be like we're starting with 92, and then the next even number after that is 94, and the next even number after that is 96 and 98. And I know I keep stopping after like 4. But you can, consecutive numbers can be just 2 numbers. They can be 3. They can be 15 numbers. Who knows? Usually it doesn't get that obnoxious, but there's just one after another after another. Consecutive odd are just like even, but there's odd numbers. That's it. Okay, so if I do an example, consecutive odd, we could have negative. Let's just do a negative example here. We can have like negative 37, and the next odd number after that is going to be negative 35. And the next odd number after that's going to be negative 33, and negative 31, and negative 29, and negative 27. And you can see what's going on there, okay? Now, one thing that's worth noting here is that if you observe, look at your list there of even, and look at your list there of odd that I just wrote down, at least. And notice that whether they're even or odd, you can see the differences between the digits, whereas with just regular numbers, they're all 1 apart, right? You can just go plus 1, they have a difference of 1 between one number and the next every time. So plus 1 makes negative 14, negative 14 plus 1 makes negative 13, plus 1. So you can see it's got a plus 1 pattern there. But with consecutive even and with consecutive odd, it's not plus 1, it's plus 2. Whether it's even or odd, it doesn't matter. It's always going to be plus 2, because where you start is what matters. So we start with an even number and then add 2, we're at the next even number. And then we do 94 plus 2, that's 96. 96 plus 2, that's 98. And 98 plus 2, 100 plus 2, 102 plus 2. All right. Same goes for the odd. So if we add 2, so plus 2 right there, we get to negative 35. Negative 35 plus 2, negative 33. Negative 33 plus 2, and you can see what's going on there. All right, every time we're adding 2. And that's important to think about when we're setting up our equations. We're going to set up our little parts, which are expressions. We're going to put our expressions together to make an equation. Okay, so that is what we're going to do. So for number 5, it says the sum of 3 consecutive integers is 57. All right, so 3 consecutive integers. So let's just say, so the first integer, we got the second, we got the third. All right, we're going to write little expressions down here that will represent those integers. And first integer, let's say the first integer represents n. We don't know what those integers are. I know we can kind of guess and check and try to figure it out brute force wise, but let's just do some algebra here. We're in an algebra class, so we're going to do some algebra. And so the first integer is n. The next integer is going to be n plus 1, because consecutive integers, we're not talking about odd, we're not talking about even, we're just talking about consecutive, one after the other after the other. They're always going to be one apart. So the next number would be n plus 2. And if we had to keep on going, we'd do n plus 3, n plus 4, n plus 5. But those 3 expressions, n, all right? So you got n, you've got n plus 1, that's the second integer, and then n plus 2 represents the third integer. And we know that the sum of those integers, we know that sum means add, right? It means plus. So that is what we're going to do. So we're going to do n plus 1 plus n plus 2 equals 57. So there's your setup. Okay, just so you know what we did there. So this right here, that's the first integer. This right here, didn't mean to do that. My Apple Pencil has kind of a mind of its own sometimes. I think this program actually does, not my Apple Pencil. And then right here, n plus 2, that represents the third number, right? So all those together make 57. So let's go ahead and solve it. So all the n's make 3n. All the constants make 3. So you got 3n plus 3 equals 57. Take away 3 from both sides. So at this point, we're just solving it. So you got 3n equals 54. And then you have one more step left, which is divide both sides by 3. Divide both sides by 3, then 54 divided by 3 is, I believe, 18. It's 18. So there's n. So n equals 18. Now keep in mind, again, all these problems here, a lot of times with these algebra problems, I know it's a little bit frustrating, but when you're finished, don't always assume that. Always assume like there's a little bit more to do, even though you got n or x. Sometimes there's a little bit extra. Okay, so never assume that you're done with something. So, and we're not. We need to find those integers. Well, 18 is just the first integer. So the integers are going to be what? The integers are going to be 18, 19, and 20. And you can check that by adding them up. 18 plus 19 plus 20 is for sure 57. Absolutely, totally, for sure. Number 6, the sum of 2 consecutive odd integers is 11 more than 3 times the larger number. Holy cow. So we got 2 consecutive odd integers. All right, so let's make sure we know what we're talking about. So the first odd and the second odd. Okay, so the first odd is going to be represented by n. Okay, so we're going to use n there. The second odd is going to be represented by n plus 2. All right. So if the first odd is 20, the next, why am I saying 20? If the first odd is 21, the next odd is going to be 21 plus 2, which is 23. If the first odd is negative 11, well, the next number is going to be negative 11 plus 2, which is negative 9. So that's how that works. So now this one's a little bit more tricky, but let's just kind of decipher it. So we have sum means add of 2 consecutive odd integers. Okay, well, sum means we're going to add. So the first consecutive is going to be n plus 2 means equals. That means equals 11 more than 3 times the larger number. So 11 more means we're adding 11, but it says more than, right? So 11 more than means we want to put it after. We want to change the order of that a little bit. And 3 times the larger number. So the larger number between these two is represented by n plus 2, n plus 2. So that's what we're going to do. So we're going to do 3 times the larger number, 3 times n plus 2 plus 11, because it says 11 more than that, 11 more than that. And now let's just go ahead and clear parentheses. So clear parentheses on both sides. Only one side had the parentheses, so we do that. Now let's put together like terms on both sides. So now you got 2n plus 2 equals 3n plus 17. And now let's get variables on one side. So I'm going to take away 2n from both sides. Do that. Notice how, I know I say this a lot, but it's worth saying. Notice that I'm always rewriting the problem. Every time you do it in algebra, that's so important that every time you do a step, you change it, you write it down, you see it, right? That does help. I know some people try to fit everything down in like this little tiny postage stamp area, but you really, use your paper up, kill some trees here. I know it's not ecologically friendly, but use some paper. That's what you have notebook paper for and scratch paper for. All right. And we're going to take away 17 from both sides. And 2 minus 17 is negative 15. So there's n. So there's your first n. That's your first odd, negative 15. So that means your next integer is going to be negative. What? What's the next odd integer after negative 15? Is it negative 17? No, that's actually before it. So we want to go after it. So negative 15 it's going to be negative 13. So negative 15, negative 13. That's what I was asking, right? Just for the first two. Yeah. So we got it. All right, you guys are doing great. Let's keep going here. Find 2 consecutive even integers. All right, I'm going to stop there. First, I should say, first even. And the second even. All right, so the first even is n. Now notice, like for every one of these problems that we've done so far, the first integer has always been n or x or whatever letter you choose, but it's always, whether it's odd, whether it's even, whether it's just consecutive anything, it's always, the first integer is always n. Okay. Okay, so the next integer, the next even is going to be n plus 2. Okay, so there's your first and second. So it says find 2 consecutive even integers such that 3 times the second integer. So let's do that. 3 times the second integer. So 3 times n plus 2, because the second integer is n plus 2, is 14 less than. It's got then in it, so I'm going to put that after the next part. 5 times the first integer. So 5 times, well, the first integer is n, and then minus 14 from that. So 5n minus 14 is that part. Like I said, if you just pick these apart and go little by little, these are not so bad. Okay, they're not so bad for you. And so now let's clear those parentheses out. We've got 3n plus 6 equals 5n minus 14. All right, I'm going to get variables on one side. We do it this way. The reason I'm doing that is so that the n is positive. It doesn't really matter what side you decide to put the n's on. So I'm going to rewrite it. So now I've got 6 equals 2n minus 14. And now it's a 2-step equation. Add 14 to both sides. Add 14, add 14. Rewrite it. And so you got 20 equals 2n. One more step, divide by 2. Divide by 2, and then those cancel out right there, and you get n equals 10. N equals 10. So that's your first even integer, and your next one is 12. So it's 10 and 12. Those are those two integers right there. All right, that concludes this lesson. All right. Thanks for sticking around. This whole lesson I know is a lot, but when you're doing these, just pace yourselves, pause the video at any time, skip ahead if you feel like you get it. A lot of people pause the video and they skip ahead and they do the problem and see if they did it right. Then you don't have to listen to me. If you're doing them right, and if you didn't do it right, go back and watch how I did it and see what you did wrong, perhaps. But you don't feel compelled that you have to watch every single minute of me. If you're getting this, you're getting. That's good. That's good. All right. So see you at the next video.